So we just finished learning about arrays, and when we were dealing with arrays, there were a few limitations. One of the main limitations of an array was that we needed to know the size of the array at the time of creation. So when we did the example where we were reading information from a file into an array, what we had to do was assume we knew kind of the size of the number of elements in the file. Or another thing we did was we said, okay, the file is going to probably have maybe 10 pieces of data. We're going to just create an array that is size 100 just to make sure we cover everything. We have enough space, and that was wasting space. Another thing we did was we opened the file, read the content so that we can see how many lines are in it, closed the file, created the array, and then read the file again, and that was wasting time. So this is a really major limitation of arrays, that you need to know the size at the time you're creating the array. Another limitation we really didn't talk about, but another limitation is that once you have this array of size, let's say 10, you can't make it bigger, you can't make it smaller. So if I have an array that has all my students in my class, 24, let's say, and then I have another student that comes and requests to join the class, I can't put them in that array. There is no way for me after creating an array of size 24 to make it 25. Similarly, if a student drops the class, I can't remove them from my array. I still have to have size 24 and somehow keep track that one of those students dropped the class. Now, a third limitation is that all the data in the array must be the same type. It's an array of strings, it's an array of ints, it's an array of floats, and it's an array of bank accounts. All the data in the array has to be the same type. So these are limitations of arrays. And because of these limitations, Java developed another class called ArrayList, which helps with these limitations. The main advantages is that you don't need to know the size at the time of creation. You can automatically just put things in it, insert things into it, add things to it, remove things from it. You can insert in the middle. And so it's really convenient. And we're going to see how to use it today. Now, to use it, we have to import java.util.ArrayList. Remember, for arrays, we didn't have to import anything. The only thing we had to import was java.util.arrays when we wanted to sort or search the array. If you don't want to search or sort the array, you don't need to import anything. With ArrayLists, we have to import something. So and add that in. So the first thing I'm going to do is go and import java.util.ArrayList. Now, how do we create this array list? The syntax is ArrayList, and then inside the less than and greater than sign, we put the type of the data that we want to store in this array list. And then we give it a name, and then we say equal new array list. And again, we can put the type and parentheses. And we can put anything here as long as it's a class. So one of the disadvantages for Java 1 for ArrayList is that we can't put here the primitive data types. You can't put int and float and double and char and boolean. In Java 2, we will learn a way to bypass that. But for now, we can put anything like strings, student, bank account, scanner, print writer, anything that's a class. Now in Java, actually what comes here after the array list, it's optional. You don't have to put it in. So it knows already that you're trying to create an array list of strings. So this is automatically going to be an array list of strings. Okay. You can also optionally say how many elements you want your array list to start out with. So notice here, those parentheses are empty. Those parentheses, I can actually put an initial size. So if I know exactly how many students or how many names I need in my array list, I can put a number. So here it's going to create an array list that is capable of holding 10 names. This one is capable of holding 24 student objects. Now, am I limited to this? No. If I want to make it bigger later, I can. And like I said, the only drawback of ArrayList is that we must store objects. We can't do primitive data types. Okay. So let's go and start creating some array lists. So here, what I'm going to do is I'm going to create an array list that is capable of holding some strings. So string, let's say pets, new array list. And again, I'm not going to specify a size. Okay. Now, how do we start adding things into the array list? So to add, what I can do is just say pets dot, and it has a method add. And because this is an array list of strings, I can add strings. So I can say add cat. I can say pets add dog. Pets add rabbit. So I can start adding things. Now, the nice thing also of an array list is that you can print it. So I can say system.out.println pets. Now this is just for array list of strings. In Java 2, we will learn printing objects, array lists of objects. But it printed the contents for me, and it's putting them, it puts square brackets around it so that I can see that it's an array list. We weren't able to do that with arrays. I can use this print method, or I can write my for loop to print. So I can use the enhanced for loop just like I did with normal arrays. I can say for every string s in pets, system dot out. And here what I'm going to do is I'm going to put them all on one line, just so we see the difference between the printing of the array itself, array list itself, and the print method. And when I'm done, I'm just going to put a new line. So here it's going to go through every string in pets and print it out. So now I printed it out myself. Because I did the printing myself, it doesn't have those square brackets. I could use the for each loop. So this is the for each loop, or I can use the regular for loop. So I can say, well, for int I equals 0, I less than pets dot. And here notice that dot length doesn't exist. It has a different method called size. So this is something to keep track of between arrays and array lists. Array lists, it has a method called size. And then I say I++, and let's print it out, system.out.println, sorry, print. And here I need to go to pets and grab an element. So just like there's an add method to add an item, there's a get method to get an item. Okay, so I can say get me what's that I. And then again here I'll just print an empty line. So again, this will also print me the contents of the array. Okay, so here I printed the contents of the array in 3 different ways. One, just using the print method for array lists, just printing, putting the name in. And then once using the for each loop and once using the regular for loop. So far we've learned the add method, which adds things to the end of the array. So I add cat, then dog comes after, rabbit comes after. So add always adds to the end. Adds to the end. Okay, and then we learned that we can get the size of the array list to know how many elements it has, and we can grab an element by index. So if I say get me what's at location 0, it gives you the first one. Get me at location 1, it gets me the second one, and so on. Now, how about if I want to add something in the middle? Okay, so let's come here and let's add box after cat. I want to add it in the middle. So I can go to pets, and when I say add, there's a method called add, which takes an index. It takes the location. So if I want it to be after cat, that means I want it to be the second element. I want it to be at location 1. So I'm going to go to location 1 and say add fox at location 1. And so now when I print my array list, I see that fox got added at location 1. I can also change what is at a location. So let's say I want to change dog to rabbit. Sorry, to rabbit is already in there. Let's do lion. So dog now is at location 0, 1, 2. It's at location 2. So I can go to pets and say, I want you to set location 2 to lion. So it's going to go and change whatever is at location 2 to whatever I tell it. And so now it has at location 2 lion. So I can add to the end, I can add in the middle, and I can change data that's there. What else can I do? I can remove. I can remove by index. Let's say I want to remove the first element, cat. I can go to pets and say, I want you to remove remove 0, location 0. So because cat is at location 0, I'm going to say remove what's at location 0. And when I do that, there's no longer cat. It got removed. Now the nice thing about remove also is that I can remove by object. So I can say remove lion, for example. I don't have to know where lion is. So here I'll say remove, and I'll say remove lion. And my array list after I remove no longer has lion. Now, just so you know, I'm going to add a couple lions in here because the remove only removes the first instance. It doesn't remove all of them. So when I call the remove, it only removes the first one. So here, if I have 2 more, it's not going to remove them. Okay, so they're still there. It didn't remove them. So the remove by item, by object, only removes the first instance. Now let's look at pets.remove. Here, the remove by item, if I look at it, it's returning a Boolean. And it says removes a single instance of the specified element from this collection if it is present. More formally removes an element such that, okay. Remove returns true if this collection contained the specified element. If it finds it, it returns true that it found it. Now, what if it doesn't find it? It returns false. So if it doesn't find it in there, it returns false. So I can actually write a while loop to remove all lions. Okay, so what I can do is I can say remove the first lion, and let's say found. So here I try to remove the first one, and that is going to return true if it found it. So I know it found 1 because I know it has 1. So I can say while found, while it found is true, I'm going to go back and say found equal to pets.remove lion again. So if it found it, it's going to come here and say I found it. So if it found, I'm going to say, okay, since you found one, go remove lion again. And when it finds lion again, it's going to return true. It's going to come back and say, I found it. So I'm going to say, okay, go remove lion again. And it's going to keep doing that. And then until this remove command returns false. And when it returns false, this is going to stop. It's going to say it's false. It's not going to go back in it. Let's see if this while loop actually removes all lions. It did. Okay. So far we've learned adding at the end, adding at a specific location, changing a specific location, removing by index, and removing by object. Okay, so we can add, we can add at a specific location, we can change something at a specific location, we can remove by index, and we can remove by object. And we also talked about printing, where you can just print the array list and it will print all the contents with square brackets around it. Now, just so you know, if you try creating an array list and you don't specify a size, what it does, it creates an array list of size 10 by default. Once you add 10 elements, it's going to say, oh, I've reached my 10 size. I'm going to double my space. So it's going to go and create a space that's capable of size 20 and copy the contents. So if you know how big your array list is going to be, it's a good idea to create it from the start with the size so that you avoid having the code underneath copy the array. So just to kind of explain what's going on. So when I create an array list and I don't give it a size, it's going to go to RAM and allocate space that's capable of holding 10 items. Now, after I've added those 10 items, it's going to say, oh, I reached to my end. I need more space. So it's going to go to RAM and say, I need space now for 20 items. And it's going to go and copy those 10 items in here. Now, this copying is going to take time, right? It's not going to happen in an instance. It's going to have to copy one item at a time. And after it copies them, you can start inserting until you insert 10 more. And now it reached the 20 limit. So now it's going to have to double itself again. So it's going to go to RAM and grab space that's capable of holding 40 elements. And again, it's going to have to copy those 20 elements and so on. So if I know that my array list, for example, is going to hold 120, I should create it from the beginning with the size that I want. If I don't know, that's okay. And finally, just like we were able to sort and search arrays, we can sort and search array lists. To do that, we will need the help of a class called collections. Just like for arrays, we have to import java.util.arrays. For array lists, we're going to have to import java.util.collections. So let's go to our here, java.util.collections. Okay. And if I want to sort, I'll call the sort method. If I want to do a search, I'll use binary search. So it's very close to what we did before, except instead of arrays, it's collections. So what I'm going to do here, before I do any of my removing, I'm going to sort the array. Okay, so I'm going to say collections. I'm going to go to the class collections and call the sort method, which is a static method, and say sort me pets. And I'm just going to print here, before I do any removing, I'm going to print my pets array. Okay, so let's print it here. And for now, actually, let's just comment out the code below. And so it sorted the array for me. This was not the order that I put things in. I did put cat first. I did set this one to fox, but then I did my lions and then rabbit. So it sorted them for me. If I were to add here pets.add zebra, for example, I'll find zebra to go to the end. So it's able to sort them. Now, what if I want to find something? Remember, when I want to search for something, let's search for panda. Let's see if panda's in there. Okay, remember, must sort first. Remember, when we're searching, we have to sort first. So we already did the sorting. So now I'm going to call collections, and it has the method binary search, just like arrays had it. And I'm just going to here erase all that. And I'm going to search pets for panda. Now I know it's not found, so I'm going to print out what it returns. And we said if it doesn't find anything, if it finds something, it prints me the index of where it found it. If it doesn't find it, it prints -1. And so, sorry, a negative number. It prints a negative number. So here it printed a negative number, which means it didn't find it. Now, what if I want to find something that exists? Let's go and say, let's search for zebra. Now, zebra is going to be the last element in this array list. So it's at location 6. Now, if I search for something like cat, cat is at location 0 because I did sorting and it was the first element. So I'm going to find it at location 0. So you can search for items in your array list just like you were able to do with arrays. So what you're going to do for this classwork is you are going to write a class, travel info, and this travel info class is going to store 3 pieces of information: a speed, a time, and a distance. Okay, so when you go to create your travel info class, at the top here, your class is going to have 3 private instance fields, 1 to store the time, 1 to store the speed, and 1 the distance. Okay, you can write constructors, you can write get and set methods if you want. But what I would suggest doing is holding off until you actually need things. So as you find you need some get methods or set methods or specific constructors, write those. But don't write them all at the beginning. But it's going to store these 3 pieces of information. And what I want it to do is I want it to have a method called calcTime, which is going to calculate the time it will take to reach a destination based on the distance and speed. So using the distance and speed that are stored up here is going to calculate the time and set it. So this is the class. Now the main method inside your program, what it's going to do, it's going to create an array list of travel info. So you're going to have something like this in your main, except here it'll say travel info. Storing travel info objects. Okay. And you're going to ask, you're going to make it size 10. So inside the parentheses here, you're going to put the number 10 to make the size 10. You're going to ask the user for the name of a file. And this file is going to have numbers like this: 200 space 65, 180 space 70. So a sample file like this one. So each line in the file is going to have 2 numbers separated by a space. And when you read this file in, you're going to read a number. As long as the file has lines, you're going to read a number and then a number. So in your while loop, for that, the while loop that says something like input file dot has next, when you know that it has something next, what you're going to do is you're going to read 2 numbers from it. The first number is the distance and the second one is the speed. So you can have something like int distance equal to input file dot next int and int speed equal to input file dot next int. So you're going to read those 2 numbers. Now what are you going to do with those 2 numbers? You are going to create a travel info object out of them. So you're going to have to say travel info, let's say x equal new travel info, and you're going to pass in the information to the constructor. Once you realize what constructor you need, go up and write it. Now what am I going to do with this travel info? I'm going to add it to an array list. So the array list that I had, whatever your array list is called, you're going to go and call the object, add this object in it. So at the end, you're going to have an array list that has the same size as the number of lines in this file. You're going to call calcTime on each item, each travel info in the array list. And what you're going to do is you're going to create an output file with the data in the format distance, comma time, comma speed. Okay, so to get this code to work on HackerRank, you will find on Blackboard a template file. Download that template file and start adding your code into it. If you have any questions, let me know.